Welcome to tonight's video on Unit 9, Part 5, trigonometric inverse functions. Remember that an inverse and its function basically undo each other, meaning the domain of y is equal to the range of the inverse and vice versa. And if the equation is 1-to-1, then the equation and its inverse will both be functions. So if we look at sine inverse, this is where it says f inverse is equal to sine inverse of x. It is easiest first to look at the graph of the sine function. And notice it is not 1-to-1 because it does not pass the horizontal line test. So if you want to draw the largest possible rectangle, that it would be 1-to-1, assuming that you have it centered at the origin. So the origin is right here. The largest possible rectangle that you could draw would be here from negative pi over 2 to positive pi over 2. And that would make it 1-to-1. So that is the domain of the sine inverse. The range, if you notice the range, it goes from -1 to 1. And remember, what kind of object do you take the sine of? You take the sine of an angle. And what kind of object is the output of the sine? It is the y-coordinate of the unit circle. So if you look at the inverse function, the domain of the inverse function is from -1 to 1, and the range is from negative pi over 2 to positive pi over 2. What kind of object do you take the sine inverse of? You take the sine inverse of the y-coordinate of the unit circle. And the object that is the output of the sine inverse is an angle. So, the output range of the sine inverse is restricted to what angles in what quadrants? Well, if you get a positive, or if you have a positive angle, then that's in quadrant 1, and it would be from 0 to pi over 2. If it's a negative angle, it would be in quadrant 4, and it would be from negative pi over 2 to 0. All right, so for the cosine inverse, and we'll do some examples at the end, the cosine inverse is also not a 1-to-1 function because it doesn't pass the horizontal line test. And to make the largest possible rectangle where it would, with 0 being included in the domain, well, we can't do negative pi over 2 to positive pi over 2 because that wouldn't pass still. But if we include 0 and we start at 0 and then we go, let me do a different color. Start at 0 and go all the way to pi, there would be a rectangle that would allow us to have a 1-to-1 function. So the domain for the cosine, in order for it to be 1-to-1, would be from 0 to pi. The range is still from -1 to 1. That means the domain of the inverse would be from -1 to 1, and the range of the inverse would be from 0 to pi. What kind of object do you take the cosine of? You take the cosine of the x-coordinate of the unit circle. and the object that's the output would be the angle. But then for the inverse, it's the reverse. You take the cosine inverse of an angle, and the output is the x-coordinate of the unit circle. The range of the cosine inverse is restricted to what angles and what quadrants? Well, if it's a positive angle, it's going to be in quadrant 1, and that means it's going to be between 0 and pi over 2. And if it's a negative angle, it's in quadrant 2, and that means it's going to be between pi over 2 and pi. Tangent inverse. Now, tangent inverse, you have a built-in rectangle because you have between the two asymptotes. The built-in rectangle is here from negative pi over 2 to positive pi over 2 as well. So the domain is from negative pi over 2 to positive pi over 2 for the one-to-one function. The range, well, for tangent, it can be all real numbers. And then for the inverse, we just switch it around. So the domain of the inverse is going to be all real numbers. And the range is going to be between negative pi over 2 and positive pi over 2. Between those, it can't be those because those are undefined. So I should take off those like that. What kind of object do you take the tangent of? Well, the tangent is the ratio of y over x in the unit circle. And what kind of output is it? It's an angle. And then the object that you take the tangent inverse of is the angle. And the output is y over x in the unit circle, that ratio. And the quadrants are the same for the sine inverse. It is positive angle is in quadrant 1, and that is between 0 and pi over 2. But then if it's a negative angle, it's in quadrant 4. It's between negative pi over 2 and 0. So now let's do some examples here, like sine inverse of rad 3 over 2. Well, you know it's in the first quadrant, so then you have to figure out what angle has the ratio of, for sine of rad 3 over 2, so y over r, or the y coordinate in the unit circle is rad 3 over 2, however you want to look at it. And in this case, it would be 60 degrees or pi over 3. For sine inverse 1/2, that is a 30 degree or pi over 6 angle. Tangent inverse of 0, well, tangent inverse of 0 is at 0. That's because the y over x is 0 over 1. Cosine inverse of 0, well, the cosine is 0 at pi over 2. Cosine inverse negative 1/2. So now we're in the second quadrant, and the cosine is 1/2 with a pi over 3 angle, but in the second quadrant, that would be 2 pi over 3. Rad 3 over 3 is the tangent of a pi over 6 angle, because if you look at it, it is really 1 over rad 3, and the y coordinate is 1, and the x coordinate is rad 3 at a pi over 6 angle. So now the tangent inverse of negative 1. Well, the tangent inverse of negative 1, well, the tangent is 1 for a pi over 4 angle, so negative 1 would be in the fourth quadrant at negative pi over 4. Negative rad 3 over 2 for the cosine, well, that happens at a pi over 6 angle, but since it's cosine inverse, it's in the second quadrant, so it's 5 pi over 6. Sine inverse negative 1 over rad 2, that is the same as negative rad 2 over 2, which occurs in the fourth quadrant, so that's negative pi over 4. Tangent inverse of negative rad 3, that means it's a pi over 3 angle, but it's in the fourth quadrant because it's tangent inverse, so it's negative pi over 3. Cosine inverse negative 1, the cosine is negative 1 at pi. Sine inverse of 1, the sine is 1 at pi over 2. So now these composition problems, so now you're going to work from the inside out. So first you have to find the sine inverse of 1/2, and the sine inverse of 1/2 is pi over 6. And now the cosine of pi over 6, so this is just a unit circle problem. Cosine of pi over 6 is rad 3 over 2. Sine of tangent inverse of 1, well, tangent inverse of 1 is pi over 4. So sine pi over 4 is rad 2 over 2. Sine inverse of cosine pi over 4, well, cosine pi over 4 is rad 2 over 2. The sine inverse of rad 2 over 2 is negative pi over 4. Or sorry, positive pi over 4, because it's a positive angle. Cosine inverse cosine 7 pi over 4, well, the cosine of 7 pi over 4 is rad 2 over 2, and the cosine inverse of rad 2 over 2 is a pi over 4 angle. All right, so now 2 sine inverse of 1/2, well, sine inverse of 1/2 is pi over 6. 2 times pi over 6 is pi over 3, and the cosine of pi over 3 is 1/2. Sine tangent inverse rad 3 over 3, well, the tangent inverse of rad 3 over 3 is pi over 6, and sine of pi over 6 is 1/2. Cosine pi over 3, well, cosine pi over 3 is 1/2. Sine inverse of 1/2 is pi over 6. Cosine pi is negative 1. Tangent inverse of negative 1 is negative pi over 4. And last but not least, tangent inverse of rad 3 is pi over 3. And then the cosine of pi over 3 is 1/2. All right, so that concludes our video for part 5, the inverse trig functions. If you have any questions, please feel free to ask, pop onto Zoom, or just send me an email, and I'll be happy to answer any questions. Hope everything's going well, and see you guys in class.